Students, we are given this question. 19 positive 9i divided by 5 negative 3i raised to the power 15. Negative 8 positive I divided by 1 positive 2i raised to the power 15 should be shown to be as purely imaginary. Okay, so let us do this question. So first what I'm going to do, I'm going to be considering 19 positive 9i divided by 5 negative 3i. I'm going to be multiplying by the conjugate of 5 negative 3i. That's going to be 5 positive 3i, and I have to divide by the same quantity. Now this is going to be 19 times 5, you multiply that, so it's going to be 45. 5 times 9 is 45. 4, 5 ones are 5, you add 4 to that, you get 9. And then 19 times 3, 9 times 3 would be 27. 2, 3 ones are 3, 4, 5, that's going to be 57i. And then 9i times 5, that's going to be 45i. And then 9i times 3i, that's going to be positive 27i squared, divided by, this is going to be 5 squared positive 3 squared. So this is equal to 95. This is going to give me negative 27. So we have to subtract that 27. So 5, 15, 8, 8, and you take away 2, you get 6. So that's going to give you 68. You add 57 with 45. That's going to be 29102. Okay. So this is what you get, 102i with the positive sign. Okay, so that has to be divided by 25 positive 9, giving you 68 positive 102i divided by 34. Now I can rewrite this as 68 divided by 34 plus I times 102 divided by 34. 34 divides 68 2 times, and 34 divides 102 3 times. Okay, so positive I times 3. So this is for the term 19 positive 9i divided by 5 negative 3i. This is what we have got. Now we have to consider the other part. Okay, consider 8 positive I divided by 1 positive 2i. I'm going to multiply by its conjugate. That's going to be 1 negative 2i divided by 1 negative 2i. So this is going to be 8 times 1 is 8. 8 times negative 2i is going to be 16i. I times 1 is going to be I. And I times negative 2i is going to be negative 2i squared divided by 1 positive, it's going to be 4 there. So this is rewritten as 8, I squared is negative 1, right? So that's going to be positive 2 there, 8 added with 2. Now 16i with a negative sign added with positive I would give you negative 15i divided by 5. So this is going to be equal to 8 positive 2 is 10, negative 15i divided by 5. This is going to be 10 over 5, 15i over 5, which is equal to 2 negative 3i, or 2 negative I times 3. So you have got these two components. So using this we are going to solve the question. So the original question can now be rewritten. In place of 19 positive 9i divided by 5 negative 3i, we would be substituting 2 positive 3i raised to the power 15 followed by a negative sign. In place of 8 positive I divided by 1 positive 2i, we would be substituting 2 negative 3i raised to the power 15. Now this is going to be my z. Okay, now the condition for z to be purely imaginary or in other words, to show z to be purely imaginary, we have to show z is equal to negative z bar. Or on the other end, or on the other, if you want to show the other way, you can also show that z is equal to negative z. Z bar is equal to negative z. So either you can show z is equal to negative z bar, or you can show conjugate of z, that's z bar is equal to negative z. So either you can show this or you can show that. So what I'm going to do is I'm going to start off by considering, I'm going to show this, okay, I feel this is more convenient for me. So consider z bar. Now z is this quantity, right? So z bar is going to be 2 positive 3i raised to the power 15 negative 2 negative 3i raised to the power 15. This entire thing has to be barred. Now we know that from the property of complex numbers, z1 negative z2, the conjugate of the difference is equal to the differences in the conjugate. So z1 minus z2. Okay, so by this property I can rewrite this as 2 positive 3i raised to the power 15 conjugate negative 2 negative 3i raised to the power 15 conjugate. So I can have this. Now also we know that z raised to the power n and having a conjugate, the conjugate and the exponent can be interchanged. So this is going to be z bar raised to the power n. So these are all important properties you can use in solving the question. So this is going to be 2 positive 3i, the conjugate, and that is being raised to the power of the exponent 15, negative 2 negative 3i, the conjugate, and that is raised to the power 15. So this is equal to the conjugate of 2 positive 3i, that's going to be 2 negative 3i raised to the power 15 negative, the conjugate of 2 negative 3i is going to be 2 positive 3i raised to the power 15. Now I can rewrite this as 2 positive 3i raised to the power 15, right? I can place a negative sign out. So this would become, I need to have a positive sign for this, so I need to place a negative sign. So it's going to be 2 negative 3i raised to the power 15. Okay, now what is this? What is 2 positive 3i raised to the power 15 negative 2 negative 3i raised to the power 15? You see this? This is where we started with. See that? When we substituted the values for the original quantity, this is what we got for z. And what exactly we are getting here? This is the same thing. Okay, 2 positive 3i raised to the power 15, 2 positive 3i raised to the power 15, negative 2 negative 3i raised to the power 15, 2 negative 3i raised to the power 15. This is z. So substitute that. So this is equal to negative of z. But what's on the left side? The left side is z bar. Okay, and exactly, see, from this we have exactly shown that z bar is equal to negative z. So this implies z bar is equal to negative z. This is what we were achieving for. We were trying to achieve this, right? So for z to be purely imaginary, the conjugate of z should be equal to negative z. So we have achieved that. So this implies z is purely imaginary. So that completes the solution to this question, students.